In this question, we have to find integration of 2x minus 3 upon x square plus 6x plus 13, which is in the form of ax plus b upon ax square plus bx plus c. Now, if you follow the standard step, your first step is get your numerator in terms of m into differentiation of your denominator plus n. So, you should get 2x minus 3 in terms of m into 2x plus 6 plus n. If you open the bracket, we will get m into 2x will give us 2mx plus n into 6 will give us 6m plus n, and your left hand side will be same. Now, to get the value of m, we have to compare the coefficient of x. So, we will get 2 is equal to 2m, or we can say your m will be 1. Similarly, to get the value of n, we have to compare constant terms, which are minus 3 and 6m plus n, or we can say n must be equal to minus 3 minus 6m, where your m is 1. So, we will get n is equal to minus 9. So, we can say in our integration, instead of numerator, we can place m into 2x plus 6 upon n, where your m is 1 and n is minus 9. Now, let's give individual denominator. So, here your first term should be considered as I1 and second term will be your I2, and then integrate one by one. So, let's begin from your I1, and we know that to integrate I1, we have to assume your denominator is equal to t. So, we will get 2x plus 6 dot dx is equal to dt. So, our integration will be modified as this 2x plus 6 dot dx will become your dt, and we will get 1 upon t, and its integration is simply log mod t plus c1, or we can say if we substitute the value of t, which we assume as x square plus 6x plus 13, so we will get your I1. Now we have to focus on integration of I2, which is actually in the form of 1 upon ax square plus bx plus c. So, let's follow its steps. A, which is coefficient of x square, is 1. B, which is coefficient of x, is 6. And we have to obtain your last term using b square upon 4a, where your b is 6, so get 36 by 4, or we can say your required last term is 9. Here, minus 9 is constant, take it outside, just write down what we have, and then add and remove your required last term, which is 9. So, we have to take minus 9 also. So, here we can say in denominator, these first three terms will make perfect square. The root of first term, the sine of middle term, and root of last term, and 13 minus 9 will give us 4 dot dx. So, here we get 1 upon x square plus a square form, where your x is x plus 3 and a is root of 4, or we can say 2. So, using formula, we can say its integration is given as 1 upon a into tan inverse of x by a plus c. So, here we'll get 1 upon 2 tan inverse of x plus 3 upon 2 plus c2. So, if you remember the original question, your I is I1 plus I2, and we have the value of I1 and your I2 plus c, where your c is c1 plus c2. So, tada! We get our final answer. In this question, you have to integrate 6x minus 5 upon under root of 3x square minus 5x plus 1, which is in the form of ax plus b upon under root of ax square plus bx plus c. So, if you follow the standard procedure, we have to get your numerator in terms of differentiation of your denominator plus n. But here, the differentiation of denominator is 6x minus 5, which we already have in the numerator. So we don't have to follow the steps. If we follow, you will get n is equal to 0 and eventually your I2 will also 0. So to integrate this, we just have to assume your denominator is equal to t and you will get 6x minus 5 dot dx is equal to dt. So I will be simplified as this 6x minus 5 dot dx will be dt and we have 1 upon under root of t, which is actually integration of t raised to minus 1 by 2. So its integration is t raised to 1 by 2 upon 1 by 2 plus c, and to get the final answer we just have to substitute the value of t. So tada! In this question, you have to integrate 3x plus 1 upon under root of 5 minus 2x minus x square, which is in the form of ax plus b upon under root of ax square plus bx plus c. Let's follow the standard step. The first step is to get numerator in terms of differentiation of your denominator plus n. So here we'll get m into differentiation of minus x square will be minus 2x will be minus 2, and differentiation of 5 will be 0 plus n. And open the bracket, you will get m into minus 2x minus 2mx, and m into minus 2 will give us minus 2m plus n, and 3x plus 1 is as it is. Now, to get the value of m, we have to compare the coefficient of x. So we will get m is equal to minus 3 by 2. Similarly, to get the value of n, we have to compare constant terms. So we will get n is equal to 1 plus 2m, or we can say your m is minus 3 by 2, which will give us minus 2. So instead of numerator, we can substitute m into minus 2x minus 2 plus n, where your m is minus 3 by 2 and n is minus 2, and then give individual denominator. So we get two terms. Your first term will be considered as I1 and second term is considered as I2. So let's integrate one by one. Let's begin from I1, and we know that to integrate I1 we have to assume denominator is equal to t and differentiate both the sides. We will get minus 2x minus 2 dot dx is equal to dt. So minus 3 by 2 is constant, take it outside. Here our integration will be modified as this term will become dt and we have 1 upon under root of t, or we can say we have to integrate t raised to minus 1 by 2, which is easily done as t raised to 1 by 2 upon 1 by 2 plus c1. So this 2 will cancel out and we will get minus 3 t raised to 1 by 2 plus c1, where your t is 5 minus 2x minus x square. So we get I1. Now let's move to I2, which is in the form of 1 upon under root of ax square plus bx plus c. So let's follow its steps. Here your a, which is coefficient of x square, is minus 1, b, which is coefficient of x, is minus 2. So we can find out the last term using b square upon 4a. So here we'll get 4 upon 4 times minus 1, which will give us minus 1 as your required term. Now here minus 2 is constant, take it outside, and let's write down in denominator what we have. And then we have to add and remove the required last term, which is minus 1. So we also have to take plus 1. So we can say in denominator this 5 plus 1 will become 6, and after taking minus common we will get the perfect square of root of first term, which is x, sine of middle term, which is plus, and root of last term, which is 1. So here we get 1 upon under root of a square minus x square form, where your x is x plus 1 and a is root 6, which can be integrated using the formula sine inverse of x by a plus c. So here we can say its integration is sine inverse of x plus 1 upon root 6 plus c2. So we get the value of I1 and I2. So we can say I, which is I1 plus I2, can be formed by getting the summation of I1 and I2 plus C, where your C is C1 plus C2. Ta-da!